Hello, this is FlippedHarber for Precalculus. In this video we'll be going over section 7.2, the law of sines. Our objectives for this lesson are to solve side-angle-angle or angle-side-angle triangles, to solve side-side-angle triangles, and to solve applied problems, which again is just a fancy way of saying story problems. Our outline for this video is extensive. We'll talk briefly about solving triangles. We'll talk about 4 cases of triangles that we'll use in this section. We'll talk about a theorem called the law of sines. We'll go over a simple reminder, and then we'll look at solving different types of triangles. Now, when you're told to solve a triangle, basically what they want you to do is find any missing side lengths and any missing angle measures. We are no longer limiting our look to just right triangles though. So there's no guarantee that any of these angles are 90 degrees. We're going to go ahead and actually assume that none of them are 90 degrees, that this is not a right triangle. Now before we get started, we need to just talk about a convention that we're going to use through this entire chapter. Our 3 side lengths are labeled A, B, and C. Our 3 angles are marked alpha, beta, and gamma. And alpha is always the angle opposite A. Beta is always the angle opposite B, and gamma is always the angle opposite C. Whether they show you a picture of the triangle or if they just give you a list of values, you can always count on this relationship. Alpha is opposite A, beta is opposite B, and gamma is opposite C. We will stick with this convention throughout this chapter. Now, there are 4 cases of triangles that we're going to talk about in this section. You should be used to these labels from geometry. They're side-angle-angle, where we know one side and 2 angles. Angle-side-angle, where that side that we know is in between the 2 angles. Side-angle-side, and side-side-angle. Now there's another type that we're not going to talk about in this section, but I wanted to just briefly name it, and that's where the 3 sides are known. That's what we call a side-side-side triangle. Again, this is not for this section. We'll actually use these types of triangles in the next section. Now, our theorem for this section is what we refer to as the law of sines. This is a set of ratios, a set of fractions that is true for any angle measure and side length in any triangle. This is, again, not limited to right triangles. We're going to assume that nothing is a right triangle. And here we see the sine of alpha divided by its opposite side A is equal to the sine of beta divided by B, which has to be equal to the sine of gamma divided by C. Now we usually see it like this, where the sine is on top and the side length is on bottom. But there's no rule that says we can't flip this if we want to. Just make sure that you flip the other fraction as well. And before we move on, I just want to point out that usually we just use 2 of these fractions. We don't usually write all 3 fractions all together. We'll only use 2 at a time. Now, in order to use the law of sines, we need to have what I refer to as a pair. We need to have an angle and its opposite side before we can use this equation. We have to have at least one pair to use this theorem. Okay, and before we get started with our examples, just a real simple reminder that our 3 angles in a triangle have to add up to 180 degrees. Pretty basic stuff. Now let's go ahead and take a look at solving a side-angle-angle triangle. Now there's a lot of work here. Go ahead and take a moment to write it all down so that we can go through it. Here's where you would pause the video to do this. Okay, so they ask us to solve the triangle where they tell us alpha is 50 degrees, beta is 60 degrees, and A is equal to 3. So here we see that pair that I was talking about. Alpha and A is a pair where we know an angle and its opposite side. So we can go ahead and start out by using the law of sines. But as you can see here, I actually started with the easy thing first. I found gamma. Now that actually gives us the ability to find both side B and side C. So the way that we do that is we use the law of sines. I've set it up here, where the sine of alpha over A is equal to the sine of beta over B. A little bit of algebra lets us solve for B. So B is equal to 3 sine 60 over sine 50, which is equal to 3.39. Now, I didn't bother to go through all of this stuff again to solve for C. I just went ahead and replaced the beta angle with my gamma angle, plug it into my calculator again, and I find side C is 3.68. Okay, let's take a look at solving an angle side angle triangle. So now they're giving us alpha is 45 degrees, beta is 15 degrees, and C is equal to 6. Now if you look at this, I don't have a pair yet. I can't actually use this law of sines even if I wanted to right now. I have to find gamma in order to use the law of sines. Well, finding gamma is pretty simple. I'll just do that difference, and I find out that gamma is 120 degrees. Now that I have that pair where I know a side and the opposite angle, I can go ahead and set up my law of sines to find A, and A is equal to 4.90. Set up the solve law of sines for B, and I get 1.79. Now, I think this is a good time to point out a quick check that you can run after you're all done solving for triangles. Your smallest angle, which in this case is beta, it's only 15 degrees, should be opposite your shortest side, 1.79. Your biggest angle, which in this case is gamma, 120 degrees, should be opposite your largest side, which in this case is C, which equals 6. So there's a quick check for you to run to make sure that everything seems to be running smoothly. Smallest angle is opposite the shortest side. Largest angle should be opposite the longest side. Okay, let's talk a little bit about side-side angle triangles. Now, side-side angle triangles present a problem. Okay, when they give us side-side angle information, there might be one or two triangles possible. Or worse yet, it might not even be possible to make a triangle with the numbers that they give us. So let's take a look at what this looks like. And here we see graphically what it would look like if there's no triangle possible. They gave us an A value that's basically too short to make a triangle. We're going to spend a little bit more time focusing on these two where there is one triangle possible, and that triangle may be a right triangle, so A is just barely long enough. Or if if A is much bigger than B, there's only one big obtuse triangle possible. But if A is big enough, but not too big, there might actually be two triangles possible. This one right here, or this one right here. Now, we're obviously going to take a look at some examples and how to tell if there's triangles possible, how many triangles are possible, and all that stuff. Now, these problems are separated out in your homework. All of the side-side angle ones are separated out, so you'll know when to check for it. Okay, so let's solve a side-side angle triangle where there's one solution. Now, they're not going to tell you ahead of time how many solutions are possible. I am being very nice, telling you that there's one solution possible. So they tell us that A is 6, B is 4, and alpha is 40 degrees. So this is a side-side angle triangle. And the first thing we're going to do is try to find beta, because we've got a pair here, A and alpha. So we can use the law of sines to find beta, the angle opposite side B. I set up my law of sines. I move some stuff around, and I'm looking to get the sine of beta. And the sine of beta is approximately 0.429. Now I'll use an inverse sine in order to solve for this, and my calculator spits out 25.4 degrees. Now what you need to do is take 180 minus this, because this angle also has a sine that's equal to 0.429. Okay, if you took the sine of this, you'd get 0.429. If you took the sine of this, you'd get 0.429. So your calculator spits out this one, you find this one. Now you might already be spotting a problem with this angle, but let's do a little bit of math to show why there's a problem. If I try to find gamma by just doing the difference, 180 minus alpha minus 25.4 for beta, I get 114.6 degrees. That's cool. No problem with that one. But if I try the same thing with the 154.6 degrees, I got a bit of a problem. I can't have a negative angle in a triangle. So whenever you see a negative angle in a triangle, that's not possible. So that's why there's only one triangle possible with this side-side angle triangle. Whenever something funky happens, basically you throw that possibility out. Okay, so we're going to use 25.4 for beta, which means that we use 114.6 for gamma. Now I can go ahead and solve for C. So again, I use my law of sines, solve it for C, and I get 8.49. Again, a quick check. Smallest angle should be opposite my smallest side. My biggest angle should be opposite my biggest side. Now let's take a look at a side-side angle triangle where there's two possibilities. I find my sine beta, and that means that my calculator spits out 73.2 degrees. I find this angle by going 180 minus 73.2 degrees. When I find gamma with both of those angles for beta, they both give me positive angles. That's why there's two solutions. This and this work. Now, I want to just point out something here. We already know what B is, but I wanted to point out that if you run the law of sines to find B, whether you plug in 73.2 degrees or 106.8 degrees, you'll get 5 either way, which is good because B was given to us as 5. Now we have to run our calculation for C twice. Once where we plug in the 56.8 and once where we plug in the 23.2. In this case I get 4.37, and in this case I get 2.06. So two possibilities, and I need to use them both. I need to give them both as answers. Okay, so that's the end of this lesson. It's time for you to try some of this on your own. I'll see you in class, and I'll see you online.